So now let's look at some machine learning terminologies. First, we'll be looking at feature. Feature is an individual measurable property of data. A combination of feature for an observation is commonly called as feature vector. Another thing is target value, or you can call it class as well. Our desired outcome of prediction with supervised learning, the value is in the training data. This jargon means that the target value which we are expecting from the prediction of our algorithm and feature is a property of that data. Now let's look at some other things. Which ML algorithm should we use? Not all algorithms are the same. The accuracy is different, the training times are different, their memory requirements are different, their scalability is different, and there are a lot of other factors as well you have to consider. So it's good to know about all the algorithms, but ultimately it depends on you and your data set to decide which algorithm will work the best for you. Another part of ML algorithms is the testing part. There are different ways to slice and dice your training set data. You can train the entire set, you can train the percentage of set, or you can use cross-validation technique where you divide the set into subsets and generally best option is chosen. So in this first iteration, you could either use 30% of the data for testing and 70% of the data for training, or 80% of the data for training and 20% of the data for testing. Or in iteration, what you can do is you can take a certain amount of data for testing, certain amount of data for training, and then shift the test data and the training data in multiple iterations so that you cover all the data and pick the best subset, which gives you the best prediction power. So now, after we have tested the data, let's evaluate the results of our algorithm. We evaluate by using the confusion metric. Accuracy is closeness to the trueness of the overall percentage. Precision is more important for non-binary classification, and there are lots of other ways to evaluate results, and some of them are specific to the problems, like recall, F measure, and everything would be dependent upon the algorithm. That's why we'll be focusing on the projects to give you a better sense of which algorithm to use in what type of problems. Before that, let's look at the matrix. Here, it's the actual value which is true or false of the input, and it is the value given by the classifier which is true or false. Now if the classifier says it's true and the actual value is true as well, it's called a true positive. However, if the classifier says true and the actual value is false, then it's called a false positive, because we will believe that the value is true based on classifier when the actual value will be false. Now if the classifier says it's false and the actual value is true, it again would be a problem, and it is called false negative, because we'll assume that something is not there even when in actuality it is there. Now when classifier says it false and actual it is false as well, then it's called true negative, because both the results are same.